Again, welcome to Python programming language. In these lectures, we shall go through lists for multi-dimensional data, and we are going to concentrate on a two-dimensional list. So our main objective in this course is how can we store a data in the form of a table, consists of rows and columns. And that's the motivation behind this topic. So our main objective, we are going to give examples of representing data using a two-dimensional list. Also, how to access elements in a two-dimensional list using row and column indexes. Also, we're going to learn how to program common operations for two-dimensional lists, such as displaying the list values or elements, or summing all the elements in the list in a two-dimensional list. Also, how to find the minimum and maximum elements in a two-dimensional list, and also random shuffling. We're also going to write a program for grading the multiple choice questions using a two-dimensional list as an example of implementation. So processing a two-dimensional list, here we can see our diagram. We have a matrix. A matrix consists of rows and columns. So the first items in the square bracket, 1, 2, 3, 4, 5, will be one row. So we have a comma. The second and the third. So here we have items with 1, 2, 3, 4, 5 rows and also 5 columns. And we can see, and also the index always start from 0. As we all went through the list, the single dimension, always the list index start from 0. So here we can see we have from 0 to 4, which is 5 columns, and also from 0 to 4 down, which is 4 rows. So here we say the matrix 0 is the 1, 2, 3, 4 up to 5. Then matrix 1, 6, 7, 8. So again, when we store the values, the square bracket, the beginning and the end of the square bracket will be one row. Then a comma and another value in the second square bracket, open and close, that will be a second row. So here we said we can view a two-dimensional list as a list that consists of rows. So each row is a list that contains the values. And also the rows can be accessed using the index conveniently called the row index. Always again, the index starts from 0. Also the value in each row can be accessed through another index conveniently called the column index. So we will have two indexes, one for our columns and one for our rows. So for example, we have matrix 0, 0. And always the first item or the first index will be, again, the row index. Then the second index will be the column. So the intersection of 0, 0 is 1. Also intersection of 4 and 4 is 3. So the fourth row and the fourth column is 3. So now let's see how we can process a two-dimensional list. And these are the few examples we have. How do we initialize the list with input values? Also, how do we initialize lists with random values? How do we print the list items? And also, how do we sum all the elements in the list? Also, we're going to learn how to find the row and the largest sum, and also summing all the elements by columns. Also, last one will be the random shuffling. So these are some of the common operations we can do with a two-dimensional list. So let's see our first code. And again, this is Python language. How do we initialize lists with input values? So here, for example, we create an empty list called matrix. And there's no size, nothing, so we create an empty list. Then next, we are going to ask the user to enter the number of rows. So here we want the user to enter the size of the list, the two-dimensional list. So first, we use the input function and ask the user to enter the number of rows we want. Then we use the second input function again, tell the user to enter the number of columns. So that will give us the size of the list. Again, the list name is matrix. So here we say for row in range, we are using the for loop. So for row in range from 0 to the number of rows, depends what the user enter. Let's say if the user enter 10, then we are going for row from 0 to 10. Remember, for loop, when we say 0 to 10, we will go up to 0 to 9. So we don't need to reduce the index by 1 here. So for row in range 0 to 9, if it's 10, we go up to 9. We are going to add an empty new row. Again, here we are initializing the list with input values. So we initialize, again, we use the method append. Actually, we use this method in our previous list topic, the single list, or I would say single dimension list. So we use the append to, again, add an empty new row to the list called the matrix. Now, we need two loops. One loop will work with the number of rows, then the other loop will work with the number of columns. So we have second loop here for column, again from range 0 to the number of columns. We enter an element and press enter. So now we have the two rows. The first item we enter will be 0 and 0. Second item will be from 0 and then 1 and 0 and 2. So we're going to have finish one column first before we move to the outer for loop and move to the second column. Then 1, then we enter all the values. So again, this two loop depends on the size of the number of columns and number of rows that the user enter. So let's say the user enter 10 and 5. And this means when we initialize our first column to our first row to 0, the rows start from 0. Then we come to the column, we start from 0. By 0, we enter the value. So here we are going to use the range, go through all the number of columns for the first row. When we finish, we go back to the outer loop. We increase the row to the second row, which will be 1. Then we enter all the value, then 2. So what we are trying to say is that this code, we enter all the values for each row at a time. Each row at a time, not the column, rows at a time. Then each time we enter the value, we append it also. Now, when we get out of the for loop, we are going to print all the items in the two-dimensional array. So the next one is to initialize list with random values. So here again, we create our list. We always start with the number of rows. We ask the user to enter the size of the rows, also the size of the column. Our first for loop will go through the rows. Then we append it. We add a new row. Then we go to the column. We start from 0. And in this case, we are not entering the values. So we using the random values. So we call the method and the class random.rand range. The range will be from 0 to 1. So we're randomly going to enter input between 0 to 100. Sorry, 100. Then here, if the column is 10, then we have option to enter values from 0 to 9, which is 10 values. Then we go increment the row to second row. We do the same thing, 10 values again randomly. We go third row randomly. So if I enter 10, 10, then I'm going to get 10 by 10 table with random values between 0 to 100. Next, how to print a list. So here we are assuming we have 3 rows and 3 columns, 3 by 3. So if we want to print these items, we need 2 for loop. The first for loop will be for the row, and the second for loop is for the column. So we say 0 to the len matrix and 0 to the len matrix row. So here we print our first item with all the column. Then if I want to go to the second row, I don't want to print everything in one line. You want to move to the second row. So we print a new line. Before we go back to the outer for loop, increment the row to 2, then we keep going until we print everything. So here we are going to print 1, 2, 3, and 1, 2, 3 will be on the first row, then 4, 5, 6, second row, 7, 8, 9. Because after we finish the first row, we print a new line. So this 4, 5, 6 will be on the next line. 7, 8, 9 will be on the next line. Now, how do we sum all elements in a list? So here we are assuming we have 3 by 3, two-dimensional list. So we still again need two for loop. One to work on the row and the one to work on the column. And then we have total equal to total matrix, the row and the column. So when I'm in the first row, I'm going to add the first row, first column, first row, second column, first row, third column. I'm finished. So I'll go to the outer loop, go to second row, then second row, first column, second row, third column. So we're going to continue doing that until we had all the values, until the row reach the end and column also reach the end. Then here we're going to print the sum we have. Now we can also sum element by column. What we did before is like summing the element by rows. Now by column means this time the outer for loop will be the column. So we start with the first column, we come to the range for the row, then we are going to add the columns all the item in first column, then we increment the column to second column, add all the item, then we increment to third column, add all the item. So the inner for loop now is the range for the rows. So when I get to the first column, I enter the inner for loop, then I'm going to add everything in that first column. First column, first row, first column, second row, first column, third row, until we had everything for that row. Then we move to the outer loop, we increment and move from first column to second column, add everything, third column, and we keep going. After that, we print our result. So that was the concept here of summing element by column, which is almost the same as what we did here. We sum element by column. But this time, you can see that again, we have the items, we have the function for summing, and this will get the sum of the first row of say matrix 0. So the index of the mass row is 0. Now for row in range 1, because we already have the first value out to the length of the matrix, we say that if the sum matrix row is greater than the mass row, and then we are going to assign the sum matrix row to the mass row. And we assign the row to the index of the mass row also. Then we print them. And this is getting the sum of the first row in mass row. And also, we can do the random shuffling using again the concept of the random class. So we have elements already 3 by 3 in the matrix, and we want to shuffle it. So we need our row for loop to go through the rows, and the second for loop to go through the column. So the first item, random dot run range from 0 to the length maximum, we assign to I. Then random dot run age 0 to the length matrix row, we assign it to J. Then we swap. So we swap the mass matrix row, the column with matrix INJ. So here we are just soft shuffling it. So we change the values. Then later we print everything. So let's see our program passing two-dimensional lists to a function, and this is the implementation. So here we have a function named getMatrix. It doesn't take no argument, and this will create an empty list matrix with a square bracket. Then we say, okay, get the input. Using the input function, we are going to get the number of rows we need. Then for the row in range, whatever size we enter, then we're going to get input for enter the row and then str row. Then we use the append function to join it. So here we have float x for x in s dot split to split the s. And that's the value we enter. Then we return the matrix. Next, we have accumulate method, which will add previous rows together. So to get the total in a row. So I start with total equal to total plus some row. Return the total. Now we have the main method. We call the get matrix function to get and list. Then we print it. Then we are going to display the sum of the element. And the sum of the element, the accumulate function will find it for us. Here we need to invoke the main function. So the execution will start from here. We are going to get the matrix. The get matrix method will create an empty list for us. Then we ask the user to enter the number of rows, the number of columns, and then we invoke. So again, grading the multiple choice test. The continuation is here. So here, that's our main method now. The answers for the questions are what is here now. So this means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And also we have 1, 2, 3, 4, 5, 6, 7, 8. So it will be totally 80 together. So those are the answers. Now the key to the questions is what we have here: DB, DCC, DAE, AD. So this should be 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the multiple choice answers. For example, question number 1, we have on the multiple choice answers, but this is the key, the correct answers. Now we are going to grade all answers now. So for I in range, the length of the answers. So we have the answers here. We'll go through the answers. If the answers are 50, then this will return 50. We're going to grade one student at a time. So the correct count, we are starting from 0. So we say for J in range, the length of the answers we have. If the answers ij equal to the kj, then its correct answer will increment the correct count. If the answer is not equal, then we don't count it. Then here we tell the user, after we count, again, we have to go through all the process here for all the questions. Then we print the number of correct answers we have. So again, this code cannot, let's see if we can run it. So again, we cannot run it. So that would be the example, again, using the two-dimensional array. The two-dimensional array we are using here is the answers. So you can see the answer variable is 2 by 2. And then actually this is a list. So we start the list. Square bracket open and close means 1 row. So we have 8 rows and 10 columns. So finding the 2 points the nearest to each other. we can use the concept of a two-dimensional list again. Why? Because each point here have two coordinates, x and y values. So each point have two values, x and y. And that's the table we have here. So point 0, or the first point is negative 1x and positive 3. The last point 7 is 4 and then negative 0.5. So with this, we can store our data in the form of, again, two-dimensional areas. We can see here points P1 is 0 and then P2 is 0, etc. So again, let's go through this code. So here we are going to use the nearest point package or the class, because we're going to call this method to find the nearest point among whatever argument we have. So here we have our main method. We say the number of points we are going to ask the user to enter for us. So the user will enter the number of points, and then we create a list to store the points. So for I in the range, the number of points we need, if it's 6 or 7, the number of points will give us how many points we need, not the actual point. And this is where we get the actual point. You enter the x and y coordinate of the point. So we enter and we convert it to float. Then next, the P1, P2 are the indices in the point list. So we call the built-in class the nearest point dot nearest point and point. And this very method here will find the nearest point of 2 points to us. So to display the result, we say the closest 2 points are, it can be point P1 and 0 or P2 and 0. STR, because we are printing it on the screen, so we change the result to string data type. So we have P1 and 0 and P1 and 1, then P2 and 0 and P2 and 1. So that will be the conclusion of our lectures. In these lectures, our main focus is how do we store data in a two-dimensional list, more or less like a table or a matrix. And we know we deal with the rows and columns. We need two for loop to process them. Always the first value will be the rows, the index will be the rows, and the second value will be the column index size. So again, wish everybody the best and thank you for your time.